Well, hello, everyone. I'm Jason Gibson, CCO at IACMI. Innovation Insights is our monthly webinar series highlighting the people, ideas, and partnerships driving advances in composites and manufacturing across the U.S. As part of the Manufacturing USA Network, IACMI leads national efforts to scale new materials, develop sustainable processes, and strengthen U.S. manufacturing competitiveness. Before we get started, I'd just like to mention that if you have any questions during our presentation, please enter them into our Q&A section, and we'll ask them to our presenters at the end of each session. At IACMI, our mission is to convene, connect, and catalyze. We convene the composites community to share ideas and opportunities, connect industry, academia, and national labs, and catalyze real progress through collaboration and commercialization. Today's Innovation Insights reflects that mission, highlighting new ideas, technologies, and applications driving the future of composites. For those new to IACMI, we accelerate composite innovation to strengthen U.S. manufacturing and workforce competitiveness through co-funded projects, access to world-class facilities, and a powerful national network. If you're listening today and you're not currently an IACMI member, we encourage you to consider the value of joining. When you become an IACMI member, you gain more than affiliation. You join a national network accelerating innovation in composites. IACMI gives you a platform to engage, contribute, and make an impact. We'd be excited to welcome you into our community, so please visit our website and reach out to us by filling out the online form. One upcoming event I'd like to highlight as we get closer is our 2026 members meeting that's taking place in Denver, Colorado. This is a members-only event at no cost, and it's one of our best opportunities all year to connect across the IACMI network. You'll be able to network with nearly 200 member organizations, hear updates on our latest research and working group activities, and share what your company is working toward in the composite space. It's a great forum for aligning efforts, sparking new collaborations, and making sure your priorities are part of the broader conversation. And if this is your first time attending, we encourage you to explore past episodes that are available on our website. Since its launch, Innovation Insights has convened members and partners from across the composites ecosystem to share practical applications, emerging technologies, and lessons learned from active R&D and commercialization efforts. This series is designed to keep you current on industry trends while creating direct access to the people and ideas shaping the next generation of composite materials and manufacturing technologies. And today is a good example of that. So, let me introduce our speakers. Today's Innovation Insights covers three important areas in our industry: new fiber materials, next-generation lightweight composite solutions, and workforce development programs. We'll begin with Rob Klawonn, President and COO of Basalt Fiber. Rob will discuss Basalt Fiber's effort to reestablish U.S. manufacturing of basalt fiber for composite reinforcement. His session will show how the company is differentiating itself through process control, quality, and the use of 100% low-emission electricity, combining performance, cost-effectiveness, and sustainability. In addition to continuous fiber, Rob will discuss MiniBars, a rock fiber composite rebar replacement for concrete reinforcement, opening additional opportunities for composites in infrastructure and construction markets. Next, Dr. Mike Swajak, Vice President of R&D at CSP, brings deep experience advancing composite materials for the global automotive sector. Mike will present TCA Float, an ultra-lightweight composite body panel material with a sub-1 specific gravity, the first of its kind to deliver both extreme weight reduction and a truly paintable Class A surface. And then we'll close with Justin Brooks, Deputy Director of Workforce Development at IACMI, who'll present IACMI's national workforce initiatives. Justin leads programs such as America's Cutting Edge and the Metal Program, which are designed to address critical manufacturing workforce gaps. This is an area where more of our members can take advantage of what's already in place. His session will outline how these initiatives help companies build hiring pipelines, upskill existing staff, and connect with training opportunities, ranging from boot camps and workshops to K-12 engagement. So I ask that as you listen, think about how these programs can plug directly into your own company's workforce and growth strategy. So with that, I'm going to go ahead and turn it over to Rob. Rob, I'll stop sharing, and if you wouldn't mind starting your presentation.
Absolutely. Can you hear me okay?
Yep.
All Sorry, started on the wrong slide. Here we are. Good afternoon, good morning, everyone. My name is Rob Klawonn. I spent the first part of my career in composites with Toho 10X, carbon fiber manufacturer that then became Teijin. From 2008 to 2018, I was president of the United States division. Toho 10X America became Teijin Carbon America. And I also ran the pultrusion facility under Teijin at Diversified Structural Composites, which later was divested over to XL. It became XL USA. So I've got going on 20 years in the composites industry, and I'll just jump right in with rock fiber. So who is rock fiber? We're a new U.S. basalt fiber manufacturer. We're going to use, as Jason said, a proprietary 100% electrified process. And it's proven to melt at higher temperatures than conventional. I'll get into a little bit. We're undergoing a Series A fundraising at the moment. Our first plan is to build 2 million pounds per year of a demonstration line that should be commissioned in 2027, followed by 10 lines to produce 150,000 tons per year. A commercial facility, roughly 300 million pounds beginning in 2028. We will also manufacture MiniBars, a small composite reinforcement. I'll share what those are. And this technology and our aim is to be a global supplier of materials, not only for the composites industry, but MiniBars to the construction industry. MiniBars are a structural basalt fiber composite, quite disruptive as a concrete macro fiber. I'll explain a bit more. They're strong, non-corroding, replacing rebar, not just for crack control, but structural performance. They're lightweight, specific gravity similar to concrete with low emissions, replacing labor associated with that steel rebar, eliminating the need for covering concrete. Reforstech Americas is our joint venture with Reforstech of Norway, who pioneered the MiniBars. We're partnered with them. We are the exclusive seller in North America, in all the Americas, actually. And our sales began last year. So we're projected this year to sell a little more than $3 million of MiniBars. So why the name rock fiber? Our fiber will be produced directly from igneous rock, not just basalt, but we can, with our higher temperature capability, we will be able to go into the more challenging forms of rock that require higher melting temperatures, andesite and basaltic andesite, maybe even up into obsidian, wherever the silica content grows and gives us the capability to make a better fiber. Why are we unique? We're using 100% electricity to produce a high quality basalt. We can focus that energy quite intensively using electromagnetic induction. Conventional basalt fiber, in case you don't know, uses natural gas. It's energy and emissions intensive because of the opaque nature of basalt. It's difficult to get the radiant heat to penetrate deep into the bath, making for an inefficient process, limited temperature capability. It then limits you to a rock that has a low melt temperature. Basalt is one of the lowest melting rock temperatures of the Mafic family. So you end up with lower and inconsistent fiber quality. I'm sure those of you that have tried basalt fiber have recognized that the inconsistency of the fiber quality and the performance, while being better than e-glass, could be much better with the right process. So our electrification story is that we'll be low to zero emissions, buying the energy credits where we need to, but relying heavily on hydro and nuclear where we can. Gives us a 3x minimum productivity advantage versus a basalt, conventional basalt. It gives us a much higher temperature capability, allowing us to create a completely amorphous and defect-free melt. The result is a high-strength fiber of consistent quality and greater productivity with lower CapEx. So where do we fit in the marketplace? between E-glass and S-glass, there's a huge gap in terms of unit price and strength. Rock fiber will fill that gap near S-glass properties with near E-glass pricing. So our value and use will outperform both of these products. We'll be stronger, stiffer, and tougher than E-glass, better value and use. We intend to be a drop-in replacement, so you will not need to change your process. If you're buying a 1200 Tex direct roving today, you can get a 1200 Tex direct roving from us. We will deliver high-quality performance at scale to compete directly with E-glass. So if your need is 100 million pounds, we'll be there to supply it. So our value chain covering raw material analysis, we've got experts in the field advising, and our chief technology officer has more than 30 years experience in the basalt fiber production space. We'll be making fiber production using our novel and proprietary electromagnetic induction, giving us superior melting at higher temperatures, and we'll be vertically integrated into MiniBars, although our fibers will be made available for a variety of applications: wind energy, drones, marine, military, automotive, and trucking, body panels, injection molding compounds, etc. So our current footprint, we have a Houston laboratory where we're operating a small melter, characterizing rocks, characterizing filaments, and developing our MiniBar production technology a bit further. But in the future, we will have a fiber facility. I'm calling it facility number 1, roughly 300 million pounds, 10 lines, and we'll be able to locate additional facilities throughout the US or overseas, as the capital expenditures are expected to be lower than conventional basalt production technology. And if you're not aware, the US is rich in high quality basalt, especially in the Pacific Northwest. I mean, anywhere outside of Portland or Eastern Washington State, Idaho State, it's right there at your feet. And I've got a slide at the end that talks about it, but we can source all the rock we need from a single quarry. MiniBars will be strategically located in the geographic market. They're relatively small footprint, composite, pultrusion-like facilities to give us the presence in the construction markets where we're most demanded. So MiniBars, many of you may not be familiar, but it is a macro fiber additive for concrete, so it goes right into the mix, eliminating the need for rebar on site. We've had hundreds of projects under our Norwegian partner and several projects since we've taken on the joint venture here in the US. Slab-on grades, sandwich panels, tilt walls, seawalls, specialty precast, duct banks and vaults. 3D printing of concrete would also work with this additive. And what you see down in the lower left are some examples, including the Nordstrom facade rebuild that was done and featured in Ascent magazine. These MiniBars, they can finish well. The concrete can finish very well. And I've got a video I can show you. So what are MiniBars and what are macro fibers? Plastic and steel have been around for a few decades, at least. The introduction of a composite MiniBar is relatively new, with a tensile strength exceeding that of plastic and steel, and a fiber count that is equally as important to be able to flood the concrete with isotropic strength. I've got a video here of a slab being poured in Florida. What you'll notice is the workforce doesn't have to step over rebar. The rebar is included in the concrete, so it comes right in the truck. This was a 250,000 square foot slab, outdoor slab, actually for a precaster. So he wanted his own outdoor slab. He was tired of all the dust. He poured his own slab, and he liked it so much he's poured a second one, and he's on the way to pouring 2 more. This is a pretty impressive video of a seawall, a 5-inch panel without any rebar. And you can see they're loading it for testing. In total, 3,100 pounds added to this seawall panel. No rebar. It flexed without breaking.
No way.
You can hear the videographer commenting.
There it goes. Still holding at 3,100 pounds.
One more, bud.
So we're adding ductility to the concrete as well as strength. MiniBars are a fantastic, very disruptive product. If you can take out labor from steel placement, steel rebar placement, and you can take out the steel rebar, you can greatly reduce emissions. This is another very recent trial of a duct bank that's been developed by Roman Stone. They call Easy Key duct banks. These were produced with 0 rebar as a reinforcement. It passed at University of Maine testing for ASTM C1903 standards. I'll provide a little video here and let you watch as they assemble a 10-foot section in about 5 minutes. I cut the video into sections so that it would fit into this presentation. Dig the trench, lower the duct in, plug it together. I apologize, I was the videographer on this one. This was just last Wednesday. I'll speed up to the point where they get it fully engaged. The male to female end. Oops. I apologize. I must have paused. There it goes. Some final adjustments, and then they'll throw some dirt under the edges to get it resting in place properly. So in under 5 minutes, they've installed a 10-foot long, 3.6 cubic yard of concrete duct bank with 12 pipes. I believe 9 of them are 6 inches in diameter, and the top 3 maybe 4 inches in diameter each. So you can quickly install your infrastructure for a data center, for an airport, for anywhere there's a large amount of power cabling and communication cabling. These can be assembled rather quickly. What's very unique about Roman Stone is they're willing to set up an on-site casting facility. So they'll come to you if you have a large project, wherever it is in the US or Canada. They'll set up a site casting operation and buy local materials, local labor, and they'll make these as needed for your project. So what it does for the project, instead of one week to install 50 feet of cast in place, they can do it in under 2 hours. It really makes a big impact on the economics of building infrastructure for data centers and large projects. So our partners are Inductotherm, the world's leading electromagnetic induction technology company. MSP out of Chicago builds lines very rapidly and repeatedly. So we're counting on them to do the engineering and install on a rapid schedule. And as I mentioned, Norway, our Reforstech is our partner on the MiniBars, bringing that technology and all that pedigree of experience. They proved it out well over the last 10 to 15 years. Where we sit in our peer group, basalt fiber producers like Kameni-Vec in Russia, which is unavailable today, Technobasalt, 2 suppliers out of China, HG or GBF Group as they're known, Isomatex, and a couple of other small ones, but it's rather niche at the moment. We intend to commercialize it and make it mainstream and compete with glass fiber producers and S-Glass. So as I mentioned earlier, it doesn't take much. A small quarry is sufficient. 1 year supply can be dug out of the ground in the size of a football field, 30 feet thick. So what that does for us is allows us flexibility to grab rock from several different locations based on chemistry to give us options of where we get the best rock for the right product. And I know I've ended a bit early, but I'll be happy to take any questions.
It makes it perfect on time. We have about 3 minutes for questions for you. So,
Okay.
if I understand it correctly, the induction heating technology, utilizing electricity instead of gas, you're able to produce the basalt fiber at a lower cost and at capacity, at a large capacity than what traditional basalt fiber has been done. Is that true?
That's correct. Absolutely right. The electromagnetic induction field allows us to be very targeted. If you think of a microwave versus a convection oven, we can actually get the energy into the rock very efficiently and effectively and maintain melt temperatures quite easily.
And if I'm a composite company out there that wants to use your basalt fibers, can I get it from any weaver out there? I know that you're ramping up production as we speak, but how soon would a typical composite company be able to buy your basalt fiber in a standard 24-ounce woven or the standard products out there?
We'll have commercial samples available, I would say, mid next year, mid 2027. So the weavers, the sheet molding compounders like Mike, the injection molding compounders should be able to get trial samples enough to do the work they need to do to qualify it into their systems. And then with the commercial line coming on stream, I would say second half of 2028, we'll have 30 million pounds coming on stream at that time.
Great.
So we'll want to prep the entire value chain with the demonstration line next year.
Okay. Got a question that's come in. I work for a wet laid non-woven manufacturer. Will you be offering short chop fiber suitable for the non-woven process? And if so, what would length and diameter of the fiber be? And is there
Yes,
a sizing on the fiber as well?
I think we'll be offering chopped fiber for wet laid, for injection molding, for numerous applications. So my answer is yes, we'll have chopped fiber available. And if you get in early enough and the volume is sizable enough, we can tailor some of our early products for you.
Great. Well, I appreciate that, Rob. For the interest of time, we're going to move on to Dr. Mike Swajak. So if you would stop sharing, and Mike, feel free to share your presentation.
Great. Thank you.
All right. Are you seeing?
We are. It looks
Okay.
It looks
Good,
good. You're
Mike.
all set.
All right. Perfect. All right. So I'm Mike Swajak. Many of you know me. I've been with this entity this is my 27th year. Bud, CSP, Tajan Automotive, back to CSP. We tried Bud, but we couldn't do that. But I've been with IACMI since its inception, and then Carbon Fiber Consortium prior. So a lot of you have seen me there. So let's see if this will work. Oops. All right. So TCA Float is our latest offering in the Tough Class A continuum. So I'll give you a little bit of background on what Tough Class A is and how we get the reduced density. We'll look at a little bit about, just a quick overview on what it is and what makes us different. And then I want to talk a little bit about sustainability and then some of our current activities. So, to get right into the background here, I'm in the wrong screen. Sorry. Tough Class A is something we invented back in, early 2000s, to be honest with you. And what it did was we had an industry-wide problem with paint defects. So what you see on this chart here is, we had like 11 vehicle lines at Ford at the time, or parts at Ford and Lincoln. And anything that's in a bright color was defects per thousand. And then anything in the bright green is when we convert to tough Class A. So, the take-home message here is that everything we've done since 2001 forward is based on that tough Class A chemistry. Now, to go to lightweighting, you're replacing calcium carbonate and other fillers, clays, ATH, things like that, with a hollow glass microsphere. Now, everybody here probably knows hollow glass microspheres aren't anything new, but 3M came out with a high crust strength product, somewhere in the mid 2000s, and we were looking at using it in product. But what happens is, if you look in this picture, you can get poor contact. So poor contacts where you just kind of, and there's, a bubble sitting there in an SMC matrix. This is a tensile bar that we took pictures with on our SEM. If there's that poor contact, or if there's good contact but no bonding, you can end up with a fracture point, right? In an event where if you're flexing the panel. So ideally what you want is a microsphere that will bond to the polyester or vinyl ester matrix, but also to the sphere. So what you see in this next photo is, I've got some really good guys that work for me that came up with a sizing chemistry, proprietary sizing chemistry that we started putting on our spheres, that allow you to retain mechanical properties, allow you to retain your interfacial bonding strength, and give excellent paint adhesion. So with the resin matrix. So this was really the game changer. And that was the first introducing our TCA Ultralight, which I'll talk about in a minute. One other thing that we like to mention is, the nice thing about SMC, why it's always been something that the OEMs continue to go back to, is it's fully E-coat capable. Our materials go through E-coat every day. We can hit temperatures, approaching, 400 degrees, 410 degrees Fahrenheit, and survive that process. So we can go right on the body in white with the aluminum and steel panels that go through the E-coat dip and get painted for free, if you will, at the OEM. We do have many top coat facilities in-house that, some of our OEM partners choose to have parts sequenced into them, but we are capable of going through their E-coat if necessary. This is just the continuum of TCA. So, like I said, we introduced it back in, the early 2000s. The 1.9 density tough Class A was introduced on about 11 vehicle lines at Ford and Lincoln. We introduced it on the C6 Corvette, was the first place it launched at GM. And then we've had some innovations over the years. We developed a white version for the Wrangler, with the TCA, and then we tried a very short burst with the C6 with a mid density, which is a 1.5, but the true breakthrough with the bubbles came with late C7. So we introduced the TCA Ultralight on the C7 Corvette late in that model, and then launched C8 with the Ultralight. So and then moving forward, we start, as we got into Europe and China, VOCs became a big question mark for SMC. So we introduced a low VOC version that was used on and may still be used with our ex-partner, Tajan Automotive, on the Lotus Emira. But then, we continue development. So the TCA Float is the next gen that we're rolling out here, but we're looking at ultra low VOC as well, and then some colors that some of the customers want. So just a quick overview on what is TCA Float. I struggled when I was asked to give this presentation because, what is the big innovation here? Well, surely the innovation is 3M came out with a new sphere that is a lot less dense, that permitted us to go to a less than one density. Now that's not trivial. We still had to figure out how to coat it and if that coating works, and that wasn't exactly easy. And then, utilize the same chemistry, get surface appearance, and we're almost at the end of that development process. Some of the nice things, the specific strength of the material, so the mechanical properties based on density are identical to our current products. So design-wise, we can fold this into any current design that we make. Like all the SMCs, we build to a volume, and it's compression molded. So it's a direct drop-in. I can walk into the plant today and take this less than one density material, drop it into a process that's still molding our 1.9 density tough Class A, and not have to make a whole lot of adjustments. We can just kind of jump in and do a running change. So that's a really nice thing. And then, one of the things we always try to do whenever we develop something new, we try to improve. So with this case, we're trying to improve both the surface smoothness, which so far we think we've achieved, but also the VOCs and the sustainability. This part was CAMX Combined Strength Award finalist. Ironically, we lost to a product that had the exact same part. They showed a C8 decklet as well, but there's one, but we're happy to support composites across the board. I mentioned the mechanical properties, specific mechanical properties. This is side by side, black being the float, which is the new material, and the red being the ultralight, which is our incumbent material, which is 1.25 density. So again, we can design, we have in-house design that we can design parts. If we have a few, shifts one way or another, we can design around that with the part design working with the OEM engineering teams. I mentioned surface. So the top right corner here is what we call QualiSensor. It's a pretty nice tool that we installed here in the lab a few years ago. And we can really look at raw material. We can look at primed. We can look at painted. And this tool will actually read through each layer. But what you see here is you want a lower number in QualiSensor. This one here is the TC Ultralight incumbent material. 2 is a low VOC version. I mentioned our Gen 2, which was the Lotus Amira material. 3 there is something we're working on. It's a TCA Ultralight with sustainable content, which will fold right into the float. It's all kind of the same incoming, input raw materials. And then 4 there is the float. On the bottom, that is just a wave scan. It's a combined factor, so it's an agglomerated number based on one of our OEMs takes an average of a bunch of different numbers. So in that chart, higher is better, and as you can see that the float is performing very well. This next chart here is something that we're proud of and is really important moving forward. This is our low VOC development. So Gen 1 is just kind of the as molded. Our Gen 1 material had, we had some decomposition products that would create some problems for customers selling our materials in foreign countries. So we did a lot of work to bring our VOCs down. So first we got rid of the restricted materials. Then we had to target styrene. So styrene in this case is in red, and this is out of mold. To sell in countries currently with our Gen 3, which was the ultralight, we have to do a post bake, which is you see here is Gen 3 with paint bake. So we can pass all of the foreign tests with a paint bake, but ideally we want to come out of the mold VOC compliant. So this is kind of where we're at with our experimental material right now. A few tweaks left, but that's something we'll be rolling out shortly. Quick talk on sustainability. Many people on this call know that composites are great for sustainability, but we don't always get the best press, and there's some reasons for that. So, what we talk about here is the life cycle assessment. We assess for our own materials, the cradle to gate. So, your incoming raw materials, the manufacturing materials, and then manufacturing your product. And then it goes out to our customer, and that's where you see your use phase and end of life. So that's kind of where we measure, and we've done a lot of work, certified analysis, LCAs, to look at our materials. And this is just kind of an overview of that. On the far left is a structural sheet SMC, so basically a pickup box material, and that is the sheet going to our molding plant for molding. The second one is an appearance composite. So this is TCA Ultralight, not quite float yet, but as a raw material. And then the dark bar here is raw aluminum, appearance grade aluminum, so which gets stamped. On the right, this is a fully formed and painted part. So the blue bar there on the right is a painted pickup box, and the green bar is a painted SMC part. And as you can see, it's still lower than an aluminum panel that hasn't even been stamped yet. So we have a pretty good story in LCA, but that's always they want to know more. So one of the things we're trying to do is take those numbers down, and that's with the sustainability potential. On the left is a standard TCA float, and as you can see, the because of what we put into it, we're kind of limited by the filler in the glass, and then resin and other. So if you look at the right, if we can use a recycled glass, a recycled filler, and bio-based polymers, and even the IMR is natural resource, we can get up to 50% sustainable content by weight in flow. And we've demonstrated this. The parts look great, but there are supply chain issues and things like that we'll continue to work on. This is just kind of this next picture. This next one here is kind of a fun thing we've been doing for our customers. This is looking at, use phase isn't sexy. When people talk about sustainability, they always want to talk about end of life. Well, end of life is a small component of the total life cycle assessment. It's an important component, and it's something that we have pretty good work done on. But we do like to point out that composites are fantastic for the use phase. So this is something we did where we said, okay, if we had a C8 Corvette that has TC ultralight, the 125 density on right now, and we switch it all to float, what we see is about a 10 kilogram mass save on that if we switch all the panels we do. And as you can see here, this is an exploded view of our parts. That's how many panels we do now. So if you look at that, and you convert that to with the MPG and the average lifetime and the gas, for one C8 and how many vehicles they make over that 2020 on. And then, and one other thing we don't factor in here is that most Corvette owners are collectors. They're going to keep those cars a long, long time. We're saving basically 22 Olympic-sized swimming pools of crude oil. So I think that's a pretty good visual for people to see. And when we took this to the heavy truck guys, which you see here, Kenworth, they don't seem to care about weight as much because a lot of times you'll cube out a truck before you hit a weight target. But there are vehicles that do. But when we told them, well, you can save, 57 kilograms on a hood assembly, that kind of got some attention. And then if you do, those same back of envelope calculation, that's 282 swimming pools worth of crude oil, and not to mention the diesel you save on mileage and things like that. So kind of a neat story. Again, it's back of envelope, so I'm not going to certify it, but I think it tells you that, what we all know, composites, are really useful, and they really do fit into a sustainability story, and we just need to keep promoting that. We need to educate and advocate for ourselves. Current activity, we have done multiple trials now. So the first production trials were completed with lab-made SMC on Jeep Freedom panels. Hexacore is something I've talked about previously. I didn't have time to talk about today, but it's basically a sandwich core material that we use as an inner, but it's co-molded with an SMC outer, so we can still go through E-coat and still top coat it like SMC, but gives you extreme lightweight. Maybe we'll talk about that some other time. We have done prototype trial on C8 deck lids. You saw that in the Camex part. But recently, we just did our first trial that went through Bowling Green assembly. So I like to call this my Skittles picture. And we did this a couple weeks ago where we molded multiple fenders in our Huntington, Indiana plant, shipped them down to Bowling Green, and went through their top coat system. So initial response is very positive. We have some work to do, but we're very encouraged, and I think GM is as well. So what are we doing right now? System optimization is ongoing. We wanted to make a few more tweaks in the low profile package to get a smoother surface, look at a few molding things that concerned us, and then we have to dial in. We didn't dial in the molding process. We actually just went in and jumped into production because, they don't like us stepping into the plant during production, but they gave us a half a shift and we molded those parts. But we really have to do a DOE to look at molding tonnages and closure speeds and vacuum and all that kind of stuff to really dial in the process and get the best possible part. So what we're looking at is another follow-up lab molding trial, late Q1 here. We're on calendar year now. And then, sometime in Q2, we will scale up and do a production scale compounding trial. So it'll go through our compounding plant. We'll make, 10,000 pounds of this and mold this across the board on multiple programs. And try and get some through our customers' plants, and then get some real run at rate trials coming up Q2 and Q3 this year, so that we can really get a feel for this. Our customers can touch and feel it, really give us some feedback, and really be able to quote this for next gen, which, there's several programs coming up now that we're quoting on. So it's a good time for this, and I appreciate the forum to talk to this group about it. I think that's everything. Yep, that's it. So I'll take some questions.
Perfect. We got a couple questions for you, Mike.
Okay.
The first is, what's the typical glass fiber content in your TCA float? And they ask by volume, but I imagine we'd accept volume or weight.
Yeah, so off the top of my head, I think it's in one of these slides here. I can look, but honestly, the way we do glass is we do by volume, and I don't know glass contents by volume off the top of my head again, but if what we do is we match volume content. So when you go from a 1.9 density to a 1.25 density to a less than 1 density, you're going to maintain the volume percent glass across the board. So you'll go from 27% to, I don't know, 30 some percent to 40 some percent by weight when you go to the lower and lower density materials. Now that'll vary a bit because we're playing with filler packages too, and the glass microspheres are a little different than previous generation, but I would guess it's hitting somewhere around 40 by weight, and I'd have to calculate the volume. But again, we maintain volume percent across the continuum of densities.
Great. Next question. Can you tell us more about how you have improved surface finish and what you think will make improvements for your next trials?
So I have a really excellent team that I just talk about the good things they do. We work with multiple thermoplastic low profile additives. So we play with that blend based on the resin chemistry, based on the molding conditions. And then there are some filler advancements out there and some things we've worked on with our supply base. We have some excellent resin partners that can provide us some new LPA technology. So it's really it's a balancing act of the things that are out there and maybe some new things, but between the filler content and if we can get more calcium carbonate in, a lot of times we can get a better, smoother surface. But it's a trade-off, so we don't want to give up too much density. So it's a balancing act, but if you know how to formulate SMC, you could probably work your way through it.
Well, it looks like you got a great product for it. So with that, we're going to go ahead and move on to Justin. I appreciate your presentation, Mike. And if you wouldn't mind, stop sharing. And then Justin, if you would share yours, please.
Sure. All right. Should have it up now.
Nope.
Okay.
It's coming up.
Oh, let's try that again, shall we? There we go.
There we go. Looks good.
Thank you. Okay, so thanks for the opportunity to get on here and talk about IACMI's workforce programs. I've been at IACMI for about 3.5 years. My background's from the manufacturing sector, where I spent a lot of time in Tier 1 automotive and Department of Defense contract work. So I'm sure a lot of you guys have heard about America's Cutting Edge Metal Program and Integrate, which are some of the great programs we do here at IACMI. But this conversation is more about how our workforce programs can support our IACMI members and other industries that are looking to become members. So as you see here on the map, these are some areas where we know that IACMI memberships are taking place. So pretty good chunk of the country. And then if we put an overlay of our IACMI workforce partner sites, and these are typically universities, community colleges, and we do have some industry, you can see that we are in 16 states out of the 35 that IACMI is currently active in. Now, America's Cutting Edge, of course, started as a CNC machining program. It has since evolved. We cover everything from composites to smart manufacturing and metrology. And then we've also evolved into the metal program, which focuses on casting, forging, and plate rolling production. These programs are designed to be very quick and intensive, 1 week long boot camps where they're getting hands-on activities, and an online component that anyone can take that's 6 to 8 hours. And kind of getting into how some of that works and how these programs are designed. They're really designed to help build that workforce pipeline. We have K through 12 programming and outreach events where we're in classrooms. We also host events, or we partner with other organizations to host events where we're reaching large groups of students to introduce them to advanced manufacturing as a career path. And so they start gaining interest. And the goal is that they lean into our online content when they get around that high school age. And from the online content, they find themselves to a boot camp or an activity where they're learning something hands-on and really getting active. Some of the other things we do offer through our workforce development programs are internships, apprenticeships, and pre-apprentices. So some of the IACMI members have already taken advantage of our internship program, and that's something we like to highlight, that you can always apply to take on interns to help your company. And we do those in multiple sessions across the year. And then having access to trained, ready to hire employees. Although our composites training sites are small, we're looking to grow that significantly in 2026. And we're already targeting some potential sites that are in key locations to add value to our IACMI members as well. So what do we get out of the workforce development program? You want faster, smarter employees that can come online quickly, and their time to independence is shortened because of the training that was offered through some of our programs. I believe a few weeks ago on Innovation Insights, we had Winona State, which is one of our composite sites, highlight their boot camp. A lot of our boot camps are designed with industry in mind. We want the activities to be processes that are aligned with your company and what you do on the job floor. So we try to implement that. So when you were to hire these graduates from the program, they can come onto the job floor and add value quickly. So industry-driven curriculum is one thing we're always looking for input on, and faster launch of local training. These programs have really stood the test of time in the sense of workforce development programs. Although it's early in stage, we've been going for 5 years on the ACE program. It's sought after pretty heavily, and it's well funded, and our stakeholders are looking to invest in it moving forward into the future years. So our members can gain access to our national collaboration network, which is one thing that IACMI's strong suit is connecting these different partners together. As you can see here, regional partner networks where our schools and universities and community colleges that we currently partner with can engage directly with your companies and industry. One thing we can always share is our list of sites. I would say that it's one thing that makes the IACMI workforce program strong is our partner connections with the universities that actually deploy our training. Their goal is to solve the workforce issue, which is what we're trying to do here. So I know that a lot of the partners that are lined up on here, Wichita State Tech, Penn State, Texas A&M, and of course, University of Tennessee, they're willing to engage with members and help solve some of those same workforce problems that you guys have. And that's how IACMI can help collaborate and line those up. Of course, delivering local training is key. We do partner directly with industry. So if it's something, an area where your company knows that you're struggling in getting that workforce and retention, I would definitely highlight to lean into IACMI and our workforce team, which is efficient on organizing and getting those programs up and running pretty quickly. Again, our goal is really to kind of build your pipeline, direct access to these regional training partners. As you can see here in the table, just some of our boot camps that are scheduled for 2026, and we have some new composite sites that are coming online. So I expect the composites boot camps to go up significantly shorter. Really, the goal is to get these boot camps 1 week long, standardized and job aligned training so they can upskill faster. These can be used for your current employees or new and upcoming. We have a lot of companies that have partnered with us and utilize the ACE program as part of their onboarding, whether they use the online, which is free to everybody, or they sign up for a boot camp. Of course, the boot camps are also free to all those that attend, and definitely a good option to take. One thing we would love to highlight is show up and be visible. We're more than happy to share where our next boot camps and workshops, K through 12 activities are taking place. And hearing straight from the industry is so important, especially for new and upcoming generations. Kind of clear the mystique behind working in manufacturing. I often hear our goal is really to change the hearts and mind of manufacturing and get people to lean in and re-engage. So I want to talk about where we're going in our updates and redesigns of our online curriculum, as it is a large component of our program. So as you can see here, ACE CNC machining was kind of our original flagship, created with the University of Tennessee. It's about a little over 5 years old. And some of the concerns we see is, lower retention rates. And I say that knowing that our ACE CNC program has about a 20% higher completion rate than the national average of free online content, but there's always areas to improve. So you can see here in the video that's playing, as you go through all the modules, you have a PowerPoint presentation that's often talked to by an instructor, and then there's a quiz on the back end that all the participants would take. So our goal was to kind of think about moving forward, how do we better design these programs for students to take access to and stay engaged throughout the presentation. So soon, in the next few weeks, we're going to be launching the ACNC machining redesign course. This was done in partnership with the industry and our partner sites, subject matter experts in this field. And the goal was to really increase those engagement and retention rates, to have modules that are more than online quizzes and PowerPoint presentations. So we implemented more streamlined, short duration education modules, as well as activities to keep participants engaged and clicking through the content. You'll see some of those coming up here shortly in the video. This allows us to better track how often the participant that's on the content is being actually clicking. Sometimes those PowerPoint presentations can sit in the background and kind of fall to the wayside, but this ensures that our participants that are going through the content are remaining engaged, they're clicking through activities, and they're lining up those skill sets that we want them to. This online redesign is step one in a greater goal of coming back through our ACE Composites content. Currently, we have 5 advanced modules in Composites and 1 introductory. We want to redesign those to kind of be in the same vein where you can and partner with industry. So our IACMI members, we want you to weigh in and give feedback with our subject matter experts as our subject matter experts with our partner sites to redesign. So we want to make sure that you guys are engaged and leaning in, and we'll make sure to share those connections. And I think I buzzed through that, so I'm a little ahead of time. My apologies on that, Jason, but
No, that's good. That's good. I was excited when you were willing to present, because I feel like our workforce development is something that more of our members can take advantage of. We do have a few, but I think it's, very important for our members to understand this is free. If you want to have an onboarding type of training around composites, you can utilize what you guys have developed around that with their online capabilities, and they could just incorporate it easily and freely into their current process.
Absolutely, and our team is very flexible, and the online curriculum can be used in a multitude of ways. So we've got, like I said, we've got industry who are using it for onboarding and then upskilling, and then if there's feedback, we're always open to that. To modify, like the Winona State Boot Camp was really designed to serve industry in that region. We wanted to have access to those processes, so when those employees were hired from those boot camps, they're already coming with a baseline skill set that can be used quickly on the job floor.
And then you also mentioned the internships. Can you talk a little bit more about how we cost share with that? Because again, it's another free of service type of thing for our members.
Absolutely. So the IACMI internship program, it's really evolved over time, and it's grown. It seems like every session we have a whole new group of interns. I think the summer one was about 15 internships. So the cost share model is based off the size of your company and the amount of employees you have. IACMI will take on some of that burden from the internship or the intern that you would be hiring. So if you're a large company, then IACMI would cover a smaller portion of the cost. But if you're a small company, especially like startups, then IACMI can cover a larger portion of your internship or your interns' fees. And so you'll have access to a great candidate. And we do, I think one thing IACMI really does well is our matchmaking. When you apply for an intern, we work through our connections and evaluate the best intern for the job to suit your company.
And then for those out there that might be students, how do they apply to be an intern in the internship program?
So we have different waves that come online. So at the end of every session, we'll post the next group to apply for. And I would say that in this most recent session, we had to cut off the applications very early because we had so many interns. It's a balance that we have at IACMI of trying to make sure we have the right host and the right amount of interns. But I can say moving forward into the future, we look to expand on our internship model and have more interns to offer to more industries. So if you're interested in an internship program, we have the right people to put you in touch with if you're willing to be a host. And then if you have people that are interested in being an intern as an IACMI intern, we can put you in contact with the right people so they can apply.
That's great. I appreciate it, Justin. I think it's a great value that we offer, and hopefully more will take advantage of it. So thank you.
Thank you.
So I've got up on our screen now the upcoming Innovation Insights. Our next one is Monday, March 2nd. So please register for that. We do have one coming in April as well, where we're going to be focused on nuclear power. So we'll have that some engagement there as well. But with that, I want to just say thank you for joining us today. And we look forward to helping you in the future. And everyone have a great day out there. Thank you.